In this video, we're going to talk about electric motor service factors. On most of your electric motors, you will have a data plate position that will designate the SF, or the service factor. In this particular case, the service factor of this electric motor is 1.0. On some motors, you may see a different service factor. This particular motor has an SF, or service factor, of 1.25. So what do these numbers mean? Well, let's take a look at it. The service factor is the measure of the motor's ability to handle overload conditions. It indicates the percentage of overload the motor can manage for short periods without sustaining damage. Service factor is expressed as a decimal or percentage above the motor's rated power. A motor with a service factor of 1.15 can operate at 115% of its rated load. The NEMA standard service factor for a totally enclosed motor is generally set to 1.0, meaning that they can operate at their rated load continuously. A motor operating continuously at a service factor greater than 1 will have a reduced life expectancy compared to operating at its rated nameplate horsepower. A motor with a service factor of 1.0 can handle its rated load. A motor with a service factor of 1.15 can handle 15% more than its rated load. And a motor with a service factor of 1.25 can handle 25% more than its rated load. Most electric motors are designed to operate at 75% of their rated load on a continuous basis. This is done to protect the motor from any voltage fluctuations or temperature deviations during operation. With each 50-degree increase in motor temperature, the lifespan of the motor is cut in half. On small residential systems, you don't see much of this, but it definitely needs to be on large commercial applications. These are motor overload protectors, and they protect motors against such fluctuations of voltage and temperature. The overload protection is put after the contactor and before the motor, so that if there is any fluctuation in voltage, that the overload protection can shut down the motor and protect it from the overload. So there are basically two overloads that we need to be concerned about with electric motors. One is mechanical overloads. This could be bearings that are going out and starting to drag or cause the motor to torque up to maintain the proper speed. And then there are the electrical overloads. And we have done videos before on checking your incoming voltage and current imbalance. So make sure that your bearings are good, your voltage and imbalance is in line, and keep your motors healthy and happy. If you enjoyed this video, click the like button and subscribe to this channel to make sure you don't miss new videos each week. Thank you for supporting this channel.